Let's do a recap. Networks. In order to do networks, you first need to know some key terminology. So here's some examples. This is exercise 14A. If you're referring to that, we're going to look at dot point 1.1, reviewing concepts. So we're going to look at some of the terminologies for graphs. What are planar graphs? What's Euler's rule? And we're not going to touch directed graphs yet, or digraphs. We'll look at that in the later chapters. Okay? But here we go. Let's take this example over here. I think you have it in your notes as well, that sheet that I've given out. Let's recap. What's a vertice again? What's a vertices? What are vertices?
Good question.
I know. The points. Very good. And then, so I'm going to write here points to help you remember. So you got Anna as a vertice, Ethan is a vertice, Brett is a vertice, Francis, Dario, and Cora. Those are vertices. Okay, so these are vertices. I'm just going to draw arrows to remind you. What about edges? Listening, eyes and ears towards the board. Thank you. All right, we're up to it, guys. Let's focus. I know it's the last session. Here we go. I just want to recap to know what you know about vertices and edges. What are edges again? The lines. So the lines are the edges. So these are what we call edges. I'm going to highlight in yellow to remind you. These are edges right there. So connection points are edges. And then finally, what's degree? When you say, what is the degree at a vertice or vertex, what does a degree mean?
No, wait, not.
Very good. It's the number of edges connected to that point. Okay, so very similar to your matrix where you convert it to a network into a matrix. This here tells you the number. Oh, thank you. Yeah. Yeah, it's taking a while to connect. Now, it looks like it's given up on me. I'm going to have to find a different connection.
The ones that are like these.
You're winning.
All right, here we go. Are we back? Okay, cool. All right, so last one, degree. Listening. Degree tells the number of edges at each that connects to each of the vertices. Okay. Thank you, team. High energy today. Thank you, team. I don't mind if you knew this stuff, then I'm okay, but if it's coming to things that you're unsure about, so matrices, I understood that most of you understood the topic, so I was okay to give you that time. But if you are not sure about a topic, then I prefer that you're actively listening or actively taking notes, or otherwise you'll be studying ahead in your own space. But if I'm recording and I'm trying to make a video for you, the last thing I want is to have this recorded as I am doing now. Yeah, it will be annoying to click on a video link and this is what you're listening to. Yeah. So 3 things I wanted to cap on: vertices, edges, and degrees. So that's the first thing in terms of reviewing what you need to know. So in terms of concepts and terminology. Moving on to an example. So let's say this example over here. You got example 1. You got a connected graph. Shown to the right, here we go. You got A, B, C, D, E, F. What is the degree of vertex C? So here we're looking at the word degree. We know it's the number of connections or number of edges. So where's C? This is C. How many connections can you see that connects to C there? You can see 4. So there's 1, 2, 3, and 4 there. So you'd say it's a degree of 4. Now the next few questions will relate to the fact that you need to know the types of graphs. That's where my sheet that I printed out for you that you can copy down as part of your notes to answer. But the next one asks is, which vertices have a loop? So loop, there's a description for loop there, but which one has a loop? You can probably guess from the diagram there. Which connections? B and F, very good. So we have B, we have F. Degree of vertex F. What would the degree of vertex F be? How many do you see?
3 plus a loop.
No, I'm asking. So how many degrees, so what's the degree at F? Is it 1, 2, 3 only? Oh, sorry. 3? Or is it 4? 3 or 4? It is 4. Because the loop in itself is considered a connection as well. Okay, so we've got 4 as our degree. And then what is the bridge? Do we know what a bridge means? It's the term bridge. What does bridge mean? Very good. So you're meant to look at this diagram here. A bridge is where it connects essentially 2 circuits or 2 nice, what they call a pathway or a walk or a connected loop. So what we can see here, if I draw it, you can see A to B to C. This can be considered a loop in itself. And you can then see C to D to F all the way to E is also a separate loop. What connects these two together is what we call a bridge. Okay, if I didn't have A to C, technically you have 2 separate networks. So that is called a bridge. So in our case here, a bridge exists between 2 vertices. Which vertices are they? It is A and C. Okay, and then finally, draw a subgraph of this graph that involves only vertices A, B, and C. So the first thing you need to understand is, what's a subgraph? Yes, Claudia?
Just only the parts that are mentioned.
Correct. Very good. So this diagram here that you have, as long as you draw any part of it, you don't have to draw the whole thing. You can draw a bits and pieces of it. That's why it's a subgraph. But it must contain points A, B, and C. So if I were to draw it, this could be a subgraph. You could have A, B, C, and I could have A to B, B loop itself, and A to C. That would be considered a subgraph because it's a part of that graph. Okay, I could have, say, that's a subgraph. Okay, so this would be an example of subgraph because it's exactly the same except it's missing parts. Okay, so that's what a subgraph is, and that's all to revise what I printed out for you, the different types of graph you have. You have a simple graph, you have an isolated vertex, you have a degenerate graph, you have connected graph and bridges, complete graphs, subgraphs, and then equivalent graphs. Okay? So that's what I printed out for you there. Now, moving on to the next question though, they want you to then talk about a planar graph. So this is part of your study design. What is a planar graph again? What is a planar graph?
That means drawn without crossing edges.
Very good. So I'm going to write here without crossing edges. Now we know edges means the lines. So essentially if you can draw this graph without the lines intersecting each other, that's a planar graph. Okay, so right now this is not a planar graph because C to E crosses with A to D. That's a problem. You need to draw this, show that this graph is planar by redrawing it so that no edges cross. Now there's a couple of ways to do that. You can redraw A to D as A to D on the outside. And that way you would have A to D, F to E to D, B to C, And then to D, that doesn't have any crosses. Alternatively, you could also do C to E from the outside as well. Okay? So, that's what a planar graph means. Now, the reason why you need to know what a planar graph is because Euler's rule, which if you haven't got it, please copy it down as part of your notes. Euler's rule will only work for any planar graph. So it needs to have no intersections between the edges in order for this rule to work. What's the rule about? The rule simply connects what he calls vertices, edges, and then faces. So the question is, what are faces? We know what vertices are, we know what edges are. What are our faces?
It's like this, like
It's the space that you loop, the enclosed loop that you have. So if I gave you A, B, C, and D, and we did this, okay, we did this loop, you will have face 1, so that's a space 1, so that's enclosed, face 1, face 2, and there is one more face that we don't normally mention very good, the outside as well. Okay? So there are 3 faces in the example I just drew. Vertices, we have 1, 2, 3, 4. Listening. Thank you. And then edges, 1, 2, 3, 4, and 5. So if I write it down, I had faces were 3, vertices were 4, and then edges, I had 5. So according to this rule, it says that if I got V minus E, so V minus E would be 4 minus 5 plus F, which is 3, is meant to equal to 2. Let's see if that's true. 4 minus 5 is -1. -1 plus 3 is +2. Okay, so I made up this planar graph, but that planar graph follows the relationship between the vertices, the edges, and the faces. Okay? So the next 2 examples that you have here, sorry, next example is simply for you to utilize the rule. So here it says, for the graph shown on the right, redraw the graph into planar. Right now it's not planar because B to D and A to C are crossing. So you can't have any edges crossing for it to be planar. You need to redraw this, and however you draw it, it has to be planar. Once it's planar, they want you to verify that Euler's rule for this graph is true, which is what I did before as an example. Okay, so if you were to draw this, you can draw it as E to A, and then A to D is okay, A to B is okay, B to C is okay, and maybe I'll still keep A to C, and that's still planar. There's no intersections, and then I'll just make sure I connect B to D. Okay, so if I do that, now I've got how many faces? Face 1, face 2, face 3, face 4. Okay, and then you can continue on with your rules here. So how many vertices do I have? I've got 1, 2, 3, 4, 5. Okay, so I've got 5 minus E, edges. So I've got 1, 2, 3, 4, 5, 6, plus faces, 4. So you can see again, oh, that doesn't make sense. Which face have I forgotten? B to D? I thought I wrote it there.
No, not the face.
Which one am I missing? Am I missing another vertice?
Yeah, you didn't count B to D, did you? You're missing the edge.
Oh, I am too. I'm missing the edge up here. Thank you. So the edge, that should be then 7. So 5 minus 7 is minus 2. Minus 2 plus 4 gives you answer of 2. Very good, thank you. I couldn't tell where I was missing. I was missing B to D. Thank you. Okay, so that's your first exercise. Dot point 1.1 is to review Euler's rule. It is to review planars, types of graphs, vertices, edges, and faces. That's what DP 1.1 is. Okay? The second one you're already kind of done with matrix. If you remember matrices where you had to write out the matrix form, where's it again? This one. You know how you had to do the dominance and the communication matrix? That is exactly the same as what you're doing here. So 14B is essentially writing the matrix as number of connections. So you can see here, I've got A, B, C, D, E, F. So that tells me I have A, B, C, D, E, and F. That means when I draw out my matrix, it'll be a 6 by 6. So I'll have A, B, C, D, E, and F. And what they want you to do is to fill out the number of connections each one has. So from A,